So welcome to my talk about the CDM and interoperability with RDF. Now, has anyone heard of the term RDF? Because I'm assuming you haven't, or this might be an introduction. I'm assuming everybody knows quite a lot about the CDM. So this might be a bit of an introduction to what RDF is. If you know loads about RDF and you want to heckle me, then that's fine too. So a little bit about me. I'm the founder of a company called JUXT. We're about 150 people. We do a lot of work with investment banks, and we're really into open source. And actually, we didn't know about FINOS about a year ago. And last year's OSFF was my first ever FINOS event, and I just came along and I loved it. It's a fantastic organisation. So a year's gone by, JUXT has joined. We've got a couple of, we've done some open source work with TraderX, and I've been personally very interested in the CDM, but I'm no expert. I'm more of an expert in the kind of the formats and things like XML, if you've heard of that, and all of those things, rather than the CDM itself. However, I am quite want to, in the spirit of the principles of CDM, which I don't know if Ian is here, but if you go to the CDM website as a newbie and you learn, Ian, you say these 4 principles of the CDM. I'm going to be covering really this talk covers the second one, composability, in a more macro sense of the word, and a mapping to an existing industry format. RDF is an existing industry format. It was created by Tim Berners-Lee. It's really his second act. Tim Berners-Lee, the inventor of the web. If you can imagine how amazing the web actually is. I mean, how many, if you work in a bank, imagine creating a system that has got millions of nodes, cross-regional, has never had an outage and has to run for over 35 years. That would be pretty impressive. All those upgrade paths, no outages, and yet this is what the web and the interoperability of the formats has achieved. And so I think we should be quite interested in what Tim Berners-Lee went on to create, because I think this is potentially something that's even greater. So for me, this is kind of my kind of, I started to get interested in RDF around 2011. But just to give you kind of sense of what they created, RDF doesn't matter what it stands for, but it's really based on this idea of triples. So my favorite triple is the cat sat on the mat. So you've got a subject there, the cat, you've got the act of sitting on, which is, we call a predicate, which is the sitting on, and the object, which is the mat. But you might say that, well, your dog is sitting on a mat. Or you might say your pet is sitting on a mat. Is your cat allowed to sit on the mat? Is your cat allowed to sit on the sofa? So you can start thinking about metadata. When was the cat allowed to sit on the mat? In that few sentences, I've sort of said that a cat is a pet. That's the sort of type. So we can declare that a cat is a type of pet in my context. And as we build up more and more, we get more context. I put these statements into an LLM and said, well, generate me the whole scene of my cat. And I said, and the cat is on the mat, the ball is on the mat. And the LLM was able to imagine from the context of these triples much more about the scene. Now we'll come back to the importance of context later and why it helps in LLM hallucinations. So anyway, that idea of typing became RDFS, which is RDF schema, which then went into kind of more grand abstraction called OWL, right? You'll hear web ontology language. Quite excitingly, unlike many other formats like JSON or sort of XML is not quite true, they have XQuery. This format has its own kind of embedded query language called Sparkle. We don't have that with Java or kind of JSON types. I picked it up when around 2011 we were building a new system for a bank. Had to build it very, very quickly, and we had to capture lots of relationships quickly. Didn't have a database, so we just went for this thing. And at the time, I was quite excited about the composability of all of these, what they called ontologies. Because, as you can see, it was going from May 27 in a couple of years, it was really mushrooming. And right now, it's this kind of enormous mushroom cloud of different disciplines that are all hyper-connected. Why is this important? Why not just have an ontology for financial data? Well, you might say that I want to have a description of a trade, but you might also want to blend that into an authorization ontology. Who's allowed? Are the traders allowed to see this trade, or different trading desks? And that might be another ontology. And you want to blend them together because in your report it might be relevant to know who can see which trades, or whether the trades relate to kind of mortgage properties and have an ontology for risk in mortgage properties. So composability was something that was built in from the get-go. So I'm going to do some demonstrations of all these kind of things so that you can kind of get an idea of what it feels like using a mythical, made-up CDM ontology. Then in 2017, which is only really yesterday in the kind of the glacial progress of specifications, there's a new specification called Shackle, which I'm going to touch upon, which does to RDF what JSON schema does for JSON. Or really, this is where we're getting into more Rosetta territory, being able to say, I want to compose a trade of this, this, and this, and build up blocks, and be able to put things together. Like on a form, you might have name, date of birth, and address. And you might say, for my business context, I need to start shaping, thinking about shapes. The S in Shackle stands for shapes. And my motivation really for choosing to use RDF in 2011 was because I worked for Deutsche Bank on their rates risk engine, and this was a table that we had. It was a database called Grimace, and every table looked like this. And I was new to risk, and I just saw, and this is obviously a really small summary. We had hundreds of columns, and they were all labeled like this. And I couldn't see the wood for the trees. I couldn't see what these columns meant. And yet these columns were burned into every single SQL statement, every query, every piece of code, bits of Corn shell, bits of Java, bits of Python, spread everywhere. And so you couldn't possibly change CCY to anything else because it would just break everything. And this gave me this kind of sense that we've got to do better. Can't we somehow create more context and start describing in other metadata what these things actually mean? And if we did that at scale, wouldn't that be more meaningful for me as a human? And well, actually, yes, RDF did that and did that successfully. But RDF is kind of today having a moment. And the reason it's having a moment is because these LLMs on the right-hand side, they are desperate for context. And they are bothered to read all of the statements and all the metadata that we might as humans not bother with. But if you give LLMs pages and pages and pages of context, they'll look at it and they'll interpret it, and they'll give you better results. So this is why the term RDF it wasn't very fashionable. They gave it a new label called linked data. That kind of didn't quite work. And so now the new label for RDF is the knowledge graph. So if you see knowledge graph books and essays, they're really talking about the same thing. This is this idea that the web was really invented as the training ground for LLMs. We were just the creators as humans. We were just creating the training materials for the next superintelligence. The web becomes the training for the AI. Now, interestingly, all of these RDF statements through an initiative called schema.org have found their way onto 90% of the world's web pages contain embedded RDF. So these AIs know RDF like it's their native childhood, native tongue. These then, when you apply this AI that knows all about ontologies to your ontology, then all this intelligence about your data can be applied to your databases. So your LLMs, automatically, you bring them into your organization and you say, hey, I get this. I can understand what that risk table means, and it can actually then produce very helpful tools. So this is kind of why it's timely. I'm going to give you a quick demo. I've got about 15 minutes left, and then hopefully we'll have some time for some Q&A. I'm going to have to huddle a little bit down, but anyway, right, here we are. So, yeah, I mean, this is what the CDM looks like if you're a Java library, if you're a Java program, right? If you're a Java developer like me, you look at that and you think, wow, that looks like there's quite a lot of code there. There's quite a lot of maintenance I'm going to have to do. If you squint at it, you can sort of see some kind of relationships and stuff. But what happens if the CDM changes next week or there's a new version? I've got a problem there. I've got a load of code that I've got to maintain. Really, we really prefer a data format. And I'm not very good at ranting about this, but I know somebody who is. There's a guy on the web called Rich Hickey. He was the inventor of the closure programming language, and he has a very famous talk at Strange Loop called Simple Made Easy, where he rants about Java and Java objects. And he says, look, this is a servlet request. Look at all the names. Can you kind of see the data? And this has just come from, it's really just starts off life as some data. But somehow we've kind of turned it into all these names and kind of, we've encoded the data structure into a form that if the data structure changes now, we're lost. We can't update it. So we get this problem now. Again, we get this problem of coupling. You'll see this word coupling. This comes up a lot in engineering. This is coupling of SQL statements to their databases, the coupling of Java objects to data formats. It's kind of everywhere. But if we can get rid of coupling and we can create something much more much more dynamic, and that's really what the web is able to survive changes in data formats. That's what we're trying to get to. All right, so rant over. This isn't really the only choice you have at CDM. You do have this, okay? So this is the JSON representation. It's in one of the demo folders in the GitHub repo. But still, if I was nitpicking, we don't really see any URLs here, right? We've got something, party one, is that unique? Is that within the database? How do I find more about that party? There might be some IDs, but we've had to kind of recreate the idea of a unique ID here because that's what a URL gives us. And we've got, is this kind of an ISO format? What's going on? What does actually this period, multiply, and period means? Do I have to have a relative date? Well, and there's so many questions you might ask of this if you're an LLM, if you've seen it for the first time. Can we improve on this? Well, yeah, I think if I show you, this is on schema.org. This is a similar JSON document, but it's talking about a taxi. But up here, we've got, this is JSON linked data. Do you remember LD was linked data? JSON LD is a kind of way of bringing in RDF ideas, like a Trojan horse, into the city of JSON. Just make it a bit bigger. So at the top, we have a context. And if we go to schema.org/dentist, it's going to tell us that we need to have name, description, and what these things mean. So it's a way of bringing in some formality into JSON. So let's go into CDM now. So when I proposed to give this talk, and you'll see in the synopsis, I did say, it turns out that it's straightforward to express CD models as RDF data. And that term, straightforward, I think was a forward-looking statement and doing a lot of heavy lifting. It's not so, what I wanted to show is a complete, I wanted to move all of the types or create an output format for the CDN, which is output RDF. But because it would have taken me, I would have to write a Rosetta parser and I would have to get really deep into the way that Rosetta works. So instead, what I've done is just imagined what a CDN trade would look like. But I'll make that slightly bigger. So you can see straight away that we've got kind of URLs here. This is my trades 1, 2, 3. I was very frustrated at Deutsche Bank because we used to have these errors where it was a summit trade and it would have a summit trade ID, but I had no idea how to get more information about the summit trade. And if only it was a URL, I'd be able to put it into my browser. And if I was authorized, I'd be able to see more about that trade. And so this is this idea that we're giving a trade a unique name, not unique in our organization, but in the entire world, because it's starting with mybank.com. So this URL now is completely unique. And we can create other ones. In this example, there are references to the same expiration date and they're copy and pasted throughout the trade. Here we can just give that a URL. So we're able to address things deep into the structure and give those URLs. Now, this is a format called Turtle. And RDF you can have dozens of formats. There's formats in XML, in JSON, and other things. But this is quite nice to author. And what I've done here is I created these triples. So this is saying 1, 2, 3 is a type, which is this RDF of trade. That's wrong, actually. It should be RDFS. But yeah. See, I made this up. Don't worry, we'll get to it. Then we're saying that the trade 1, 2, 3, this is its product. And then we're going to this kind of other node here, which is kind of between these brackets. And this blank node is saying, I have some economic terms, and the economics term's missing, and now I have a payout. So all of a sudden, we've started to use something, a familiar hierarchy to ourselves, but everything here is addressable. Then I asked, so we mentioned that we can have a query language. So this is the same trade, and this is what Sparkle looks like. And I can say, here's my CDM namespace, and I can refer to these. This is it tries very hard to be an SQL statement. But here we're saying, give me all the trades, settlement types, currencies, and so on that have these relationships. Okay, I'm going to run that, and we can. So there we have a result here. This is just kind of standard tooling. And we found a trade 1, 2, 3, that matches, and we're pulling out the currency and period. Let me show you that again with the settlement. And then I've got another form of the same query here, just because it's kind of easier if you're interested in the hierarchical form. Might be a bit easier to read. But hey, that's something that we don't get really out of the box with the CDM, the ability to just query without a database. Then I asked, well, I was going to complete the rest of the trade, but I got an LLM to do it for me this morning. So these are a couple of trades, just to show you what it looks like. Let's do a query. This is a query, but I've asked for results to be in CSV. So I'm getting the results as CSV. Let's have a look at this query. So this is slightly different, but I'm going off to a data source here called DBpedia. And I'm saying, give me all the currencies. Now, we're going off to Wikipedia, and that might not be something you want to do, but there's no reason you can't have something internally in the bank that's giving you the list of currencies. So let's run that. I think we're not on the internet anymore. Not to worry. Let's go back to our trades 2. Let's say that we wanted to convert this to JSON. There we are. It's JSON on the left, turtle on the right. I can even this is it in its XML form, and let's convert it to this format here is called N triples, and it's saying give me just all of the statements that are all of the edges of this graph. In fact, 10 years ago when we were building this very small system at Deutsche Bank to allow people to access risk reports, it was a system called MIS3. We had hundreds of different users, and we didn't have time or the ability to get a database provisioned by the infrastructure group. So all we had was a file system. So we saved all of the database as these files, as these little triples. And every time somebody put a new report in or configured the system in a different way, we just wrote more and more of these lines. Trouble is, when the system had to be restarted, the system had to slurp in all of these lines to reconstruct its in-memory database. But it worked, and it worked for 10 years. I don't think the support people were very happy. It was only designed for a couple of months. But this, this was fine. We just had a log file. This is a way of writing out a database. So. And finally, I got an LLM to create a shape. So I said to the LLM, could I just have, I might even have it here. No, we're not online, are we? Are we online? Yep, we are. Okay, so we're going to, was it shapes? Yeah, here we are. So I just asked it, here's my trade. I said, yeah, here is my trade. Can you just give me an interesting query? And because the LLM knows all about Sparkle, it was able to just generate this for me, and this is what I was showing just now. I think I did ask it for some shackle. No, I can't see that. Anyway, I'll show you the shackle here. So this looks very similar, but what we're saying here is that we're creating a shape, and we're saying a contract has to have a global key, and it has to have at least one has date. So this is how we can enforce constraints. This is what Rosetta is doing, essentially, in one of, apart from the other things that Rosetta does. A key thing is saying, in this context, this bond or this option has to have these attributes. Okay, so yeah, that's it really. I hope that this has given you a quick introduction to what I think is sort of an alien superpower that we discovered a long time ago that hasn't really become mainstream. But that's not to say it won't. And there are technologies that have been out there for a long time, like Python, which was around in 1994, only had its breakout moment when data science landed and people needed to use it. Same for Postgres. Postgres was invented in the 80s, and it took a long time to have its moment. So I think for various reasons and convergences that are happening, it's worth looking at RDF as a kind of potential, another common output format that the CDM can produce. produce. I think it has some very different and very flexible, interesting ideas behind it. It's also very, very well established in many, many other financial institutions, not especially non-financial, but there's things like FIBO, XBRL, FRO, and the kind of other ontologies that you can sort of mix it in with. I did have actually in that trades 2 right at the top, you might have seen I was trying to demonstrate how you can compose with other ontologies, like for example contracts and currency amount from other sources, and this is the EDM Council that produced FIBO, and I had even a link to FPML there. So anyway, some really, really powerful stuff there. It'd be interesting to see if we could arrange something, maybe one of the hackathons, to have a go at porting the whole on CDM from a common domain model to this common data model. Thanks very much. Is there any questions? We've got 5 minutes.
You said you don't use a database. If you were to use database and RDF, what would be your preference?
Yeah, it's a good question. There are, I mean, we have this is going to be a shameless plug for a database called XTDB that we've produced at JUXT, which is particularly relevant because it allows you to put JSON documents in and then query them with SQL. So there are other solutions. For example, you could have JSON documents in MongoDB, so these key value databases. They're kind of slightly more difficult to query complex joins. You can use, there are some triple stores. The triple store that we used at Deutsche Bank was called Jenna. There are things like Ontotext and a number of others that if you really want to keep everything native. But really the advice is to say, let's make this RDF a kind of reporting format or a format for the outside for interoperating between systems. It doesn't really need us to convert all of our systems to be native RDF. It just means at the boundary, at the API layer, we can interchange through common formats, which is really what we do with this CDM. We don't put the CDM directly into databases, or at least we make that a problem for the adopter. Yes?
Is this just a concept that you've come up with, or do you have like a real world?
Yeah, it was just a concept. It was really just a sort of, I was a bit worried actually, because I was I don't know whether this talk's been given before. I'm new to the CDM, whether I'd get kicked out of the conference or whatever, because it's quite a sort of radical departure in many ways from the Java-centric or code-centric form of the CDM. But I think actually they both complement each other, and it's certainly, you could imagine the CDM next year issuing RDF files as one of the output formats that it supports. But yeah, I didn't do the work to do that, and I think it would probably be a good few days. And I think that I also looked around for a Rosetta parser, because I really felt I needed some kind of G4 Antler Rosetta parser to slurp in the Antler to actually really. I did try to use the JSON schema output format, but there wasn't enough information in there to do what I needed to do. So yeah, it's still a kind of exercise left for someone else.
For the syntax, basically, you can access the code generators, so they can help you have all this information from the root yourself, and then translate.
So do it in Java using the memory model of the Rosetta.
Just to generate the specification.
Yeah. I kind of wanted to cut it by hand just to see what before writing a generator, just to have a target so I could see what it would kind of play around with it when it's handcrafted, and once you got everything right, to then write the generator. Yeah, thank you. All right, thank you very much.